Right now, somewhere off a fishing boat, a deep-sea angler is reeling in a catch from several hundred feet down, and by the time it breaks the surface, it barely resembles the same animal anymore. Its eyes bulge outward, its stomach pushes out through its own mouth. In extreme cases, the fish looks like it's been turned partially inside out. It happened in minutes. No injury from a hook, no predator attack, just the trip to the surface. So what actually does this to a living animal? The answer starts with something most fish are carrying around without even thinking about it. A swim bladder, a gas-filled organ that helps them control buoyancy. At depth, that gas sits under enormous pressure, compressed into a small, stable pocket. As long as the fish stays at that depth, everything works fine. But here's where things get strange. Pull that same fish upward, and the pressure surrounding it drops fast, while the gas inside its body doesn't drop with it right away. According to basic gas laws, when pressure is cut in half, trapped gas doubles in volume. A fish hooked around 33 feet down already experiences a full doubling of the gas in its swim bladder by the time it reaches the surface. Go deeper to around 100 feet, and that gas can expand to 4 times its original size. That expanding gas has nowhere safe to go. It pushes outward against the surrounding organs, and this condition even has an official name among biologists and fisheries scientists: barotrauma, meaning, quite literally, pressure injury. This is the part most people don't expect. The swelling swim bladder often crushes against the liver and heart and can force the stomach to invert, pushing it out through the fish's mouth as the surrounding pressure vanishes. The eyes can bulge outward too, sometimes dramatically, a symptom fisheries biologists call exophthalmia. And it's not only about the gas that was already trapped in the swim bladder. Gas dissolved directly in the fish's blood can also come out of solution as pressure drops, forming bubbles inside blood vessels and tissue, a process governed by the same basic physics behind decompression sickness in human divers. Except there's one problem researchers have found isn't as simple as it sounds. Not every fish reacts the same way. Some species, like trout, salmon, and lingcod, have a duct connecting their swim bladder directly to their digestive tract, letting them release excess gas gradually as they're pulled upward, similar to a controlled burp. Other species, including many rockfish, walleye, and perch, lack that duct entirely, and instead have to release gas slowly through their bloodstream and gills, a process far too slow to keep up with a fast trip to the surface. Some deep-dwelling species, like certain lingcod populations caught from very deep water, don't even have functional swim bladders at that stage of life, meaning their injuries come almost entirely from dissolved gas rather than a swelling organ. For decades, anglers tried to fix this by venting, puncturing the swollen area with a hollow needle to manually release trapped gas. It sometimes worked, it also sometimes didn't, and could cause additional internal injury if done incorrectly. Today, fisheries researchers and wildlife agencies increasingly recommend a different approach: descending devices, weighted tools that carry a fish back down to depth, letting the surrounding pressure recompress the gas naturally and giving the fish a real chance to recover and swim away. But here's something scientists are still working through. Even the physics itself may be more complicated than the simple math suggests. Recent modeling research has shown that basic gas expansion equations don't always accurately predict what actually happens inside a real fish under real-world pressure changes, meaning the true mechanics of barotrauma involve more biological complexity than a straightforward volume calculation. So here's the full picture. Deep sea fish don't explode because something attacks them, or because the ocean is trying to punish them for leaving. It happens because their bodies are finely tuned instruments built for a specific pressure, and removing that pressure too quickly overwhelms systems that never evolved to handle rapid change. The ocean isn't empty, it's simply waiting for us to discover what's still hiding below. If you enjoy exploring the unknown, there's plenty more waiting beneath the surface.